Hello, geometry students. We have our last section of the summer, 13-6, and we have some new vocabulary. And the new vocabulary is mutually exclusive. Okay, we also have complement. Okay, so those are going to be our two new vocabulary. So let's look at identifying mutually exclusive events. Okay. Han draws one card from a standard deck. Determine whether drawing an ace or a 9 is mutually exclusive or not mutually exclusive. Explain your reasoning. Now, they are mutually exclusive because you cannot draw an ace and a 9 at the same time. So let's consider them mutually exclusive. Aces and 9s don't have anything in common. There are no common outcomes. A card cannot be both an ace and a 9. Okay, now Han draws one card from a standard deck. Determine whether drawing a king or a club is mutually exclusive. Well, you could draw a king that's not a club, or you could, maybe like the king of diamonds, right? Or you could pick the king of clubs. Whoops. Clubs. If I could draw a club. Okay? So, the events are not mutually exclusive because a king that is a club is an outcome in both events. Okay. So here's something for you to try. Check your progress. Go ahead and pause your video. Determine whether drawing a candy bar or an apple is mutually exclusive. All right. The events are mutually exclusive. Okay. For Halloween grab bag, Mrs. Roth has thrown in 10 caramel candy bars, 15 peanut butter candy bars, and 5 apples. Okay. Can you draw a candy bar and an apple at the same time if you only pick out one thing? And the answer is no. So the events are mutually exclusive. Okay. Determine whether drawing a candy bar or something with caramel. Well, you could draw a candy bar that has caramel. So you could draw a candy bar and draw something that has caramel in it at the same time. So these events are not mutually exclusive. Okay, how do you find the probability of mutually exclusive events? Well, if two events are mutually exclusive, and we're trying to find the probability that either one of them, A or B, occurs, all we have to do is add up the two probabilities. So the probability of A or B is equal to the probability of A plus the probability of B. So here's an example. Trevor reaches into a can that contains 30 quarters, 25 dimes, 40 nickels, and 15 pennies. What's the probability that the first coin he picks is a quarter and a penny? Well, these events are mutually exclusive. And since the coin pick cannot be both a quarter or a penny, okay, so we're going to end up an or statement, quarter or a penny. You can't be both, so we have to do one or the other. So the probability of a quarter or a penny would be 30 out of 110 plus 15 out of 110, or 45 out of 110, which reduces down to 9 out of 21. Okay, here's something for you to try. Go ahead and pause your video. If he reaches into a grab bag and selects a marble, what's the probability that he selects a red or a mixed color marble? Well, if you said 20 out of 18, that doesn't even make sense, does it? It can't be 20 out of 18 as a probability. Let's figure out where this book went wrong. Okay, so we have, looks like, a total of 15 red marbles, 20 blue marbles, 3 yellow marbles, and 5 mixed color marbles. And it says, if he reaches into a grab bag and selects a marble, what's the probability he selects a red or? So we're doing a probability of red or mixed. So we're going to find this by taking the probability of red, and we're going to add that to the probability of mixed. Well, first of all, we need to know the total of how many marbles are in the bag. Okay, and so that would be 35 here and 8 here. So 35 and 8 is 43. So we have 43 marbles. Okay, so the red ones, you have 15 out of 43 chance of picking a red. In the mixed one, you have 5 out of 43. So you have 20 out of 43 is the final answer. Somehow they got an 18 down here. So it should be 20 out of 43. I knew there was a mistake. And anyways, the probability can't be more than 1. All right, probability of events that are not mutually exclusive. So if two events have something in common, then you cannot find the probability of A or B just by adding up the two probabilities. You are then going to subtract out what they have in common. Okay, so here's an example using a chart. What's the probability that Namako selects a watercolor or a landscape? A watercolor includes these three, right? Or a landscape, which would include these others. So we have 12 this way, right? For the row, watercolor. In the landscape, we have 11. Now, we have a total then of watercolor being 12 out of the total, and then we have 11 out of the total, and the total can be found by adding these all up. So we have 4, 5, 6, 7, 8, 9, and then we have 8, 9, 10. Looks like we have a total of 30. Because the columns are add up to 30, and so would the rows. But let's put 30 down here. Now, you can't just add these together. So we can't say the answer is 23 out of 30. And the reason is, that would mean that we included this one right here twice. We included it in the row, and we also included it in the column. So what we must do is subtract out the 3 out of 30 from our answer. And we get 20 out of 30, or 2/3. Now, instead of subtracting out, what we could have done is not add it in twice in the first place. So we could just circle the numbers that we wanted, right? We want the 4, 5, and the 3, and then we want the additional 2, 1, and 5. And if you add those all up, we get 12 across, and then 14, then we get 15, and then finally 20. And there's our 20 out of 30, just by adding those 6 numbers up. All right. So they're going to explain then how they got their answer. And there's your 20 out of 30, which reduces down to 2/3, or about 66%. Okay, here's for one for you to try. What's the probability high school athlete selected at random, the student will be a sophomore or a basketball player. Okay. You said 27 out of 65. Let's see that, right? We said a sophomore, and that would be 7 or 6 or 3. So that adds up to 16. Okay? But then it says, or a basketball player. And that would include the 3 here, the 2 here, and the 6 here. So that would be 11 more. A total of 27. And we're going to assume that there are 65 in that total chart. So 27 out of 65. Okay, probability of the complement of an event. Okay, the probability that an event will not occur, is equal to 1 minus the probability that the event will occur. That kind of makes sense, right? So let's say on a 6-sided die, on a 6-sided die, what's the chance of rolling a 1? Well, that would be 1 out of 6. So what's the chance of not rolling a 1? Well, that would be 1 minus 1 out of 6, or 5 out of 6 of the sides. That's what it means. That's what it means to be a complement. All right, so let's look at an example of complementary events. Miguel bought 15 chances to pick the 1 red marble from a container to win a gift certificate to the bookstore. If there are a total of 200 marbles in the container, what's the probability Miguel will not win the gift certificate? Well, I think his odds, right, would be 15 out of 200 that he would win. And then we go 1 minus 15 out of 200, which leaves me 185 out of 200, which is a pretty big number. And then there is our probability, or about 93% chance that he does not win. Okay, here you go. Let's go ahead and try one. Pause your video if you like. What's the probability that Sergio will not win the gift certificate? All right, the answer is B. So, he bought 18. That would mean that he would have, an 18 out of 150 chance of winning. And then we'll do 1 minus that. Well, 1's the same thing as 150 out of 150. And we subtract 18 out of 150. And that's going to give me 132 out of 150. And then we could divide both top and bottom, okay, by 6. And that's how I get 25 on the bottom and 22 on top. All right. So here are the probability rules, okay, as a little kind of concept summary. The ones that we've gone over: independent, dependent, conditional, mutually exclusive, non-mutual exclusive, and then complementary events. If you want to take a picture of that, that'd be definitely helpful. Okay, here we're going to identify on example number 5 and use probability rules. Survey at Kingston High School, students found that 63% of the students had a cat or a dog for a pet. If the students are chosen at random from a group of 100 students, what's the probability that at least one of them does not have a cat or a dog? Okay, well, let's walk through this. We know that 63% of students have a cat or a dog. The phrase at least one means one or more. So you need to find the probability that either the first student chosen does not have a cat or a dog for a pet, or the second student chosen does not have a cat or a dog for a pet, or both students chosen do not have a cat or a dog for a pet. Because again, look what we're doing. The question is, let's go back, make sure I understand the question. Okay, it says, if 2 students are chosen, what's probably at least one of them does not have a cat or a dog? At least one of them. That means 1 or more. Okay, so we have to find 3 different probabilities, and then we're going to be adding these things up. Okay, so the complement of the event described is that both students have a cat or a dog for a pet. So we could, instead of doing 3 probabilities, we could find the probability of this event, and then find the probability of its complement. So the event A represents choosing a student that does have a cat or dog, and we know that that's going to be the same thing as the event B, the student that does have a cat or dog, after the first student has already been chosen. The 2 dependent events, since the outcome of the first event affects the probability of the outcome of the second event. So what we have is 63 out of 100. That's the chance the first one does have a pet. And if the first one chosen does have a pet, right, then we're going to then choose the second student from a smaller group, 99 students, and only 62 of them would then have a pet. So we can multiply this together, right, and then we end up with our answer of 217 over 550. But we know that's not the answer, because that's the likelihood that they both have a pet. So we can subtract that from 1, and we get 333 out of 550, or about 61%.